Because it is continuous and it goes on forever, every single linear equation must cross the x-axis. Every single one except one exception we will get to later. Every single linear equation must cross the x-axis, and therefore it must have an x-intercept. There's one thing about the x-intercept. It'll be where the line crosses the x-axis, and notice that it crosses right here. But any single point that's on the x-axis, there's something they all have in common, and what that is they all have a value of 0 for y's. Every single point on the x-axis must have a y of 0. And this particular one right here, when we talk about x-intercepts, it's understood that it's that value on the x-axis. And usually if someone asks you what the x-intercept is, you would look at this and probably say 2. But understand, it is a point that's on the line. Okay. Y-intercept. That's where the line crosses the y-axis. And one thing that every single point on the y-axis has is they all have in common that they all have an x of 0. Notice that x of 0. And so when we talk about the y-intercept of a line, we're usually referring to this number right here, or that y-coordinate. So it would be this number right here, which is of course 4 on the y-axis. But remember, this is a point that is on the line, and that this x and y satisfies this linear equation. So if we do have 2 points that we know are on the line, and that we know that 2 points define the line, it makes it a very easy way to graph. And we set up a very simple t-table, and that will give us 2 important points, the x-intercept and the y-intercept. And it's very simple to find those particular points, because all we have to do is substitute the y equals 0 and the x equals 0 and solve. So if I say y equals 0 in this, okay, if this is 0 here, it's just 2x plus 0 equals 4. Obviously 2 times something equals 4, and that's what gives us our 2 right here. Same with the y-intercept. If x is 0, remember this is just a 0, so what's y going to be? 4. It's really simple. We'll even use a method called the cover-up method in our next examples. Okay, so we're going to go ahead and graph this equation by using the intercept method. I'm going to have my little intercept table, or it's just like a mini t-table, but I'm only going to have 2 points. And the first point I'm going to look for is my x-intercept. That's where on the x-axis that this line crosses. So I have y equals 0, because I know that every single point on the x-axis must have a y of 0. Now I mentioned the cover-up method. If y is 0, if this y is 0 right here, I always think of it this way, and if I have it on paper I usually use my thumb, but I just cover this term up because it's basically going away. And I want to know where on the x-axis it crosses. Well, this will give that to me. You probably do it in your head. 4 times something equals 12. Well, that something obviously is 3. And when I plot that point right here and label it, this represents my x-intercept. For my y-intercept, I know that all the points on the y-axis are 0. So I can take the x term and just cover it up. And again, probably do this in your head. Negative 2 times something is 12. That would be negative 6. This represents my y-intercept. Label it. And now it's just a matter of connecting the dots and extending. And then you would use a nice straight edge and knowing to extend all the way to the boundary of our coordinate plane. So with 2 very simple points, we have graphed that line.